All right, so welcome back to everyone. A very, very warm welcome to all of you, my dear students. A very warm welcome to all of you guys. So, guys, this is the day two of 75 hard days challenge in physics, and as you know, that we already had our day one in which we have solved questions of the physics. Okay, so guys, as I said, for the next 75 days, that is next 74 days, because one day is already done. And in these days, I'll be coming up every day with some questions of the physics so that we can have them solved in the live session and you can respond to me their answers. And afterwards, we will be better in the physics. See, we always say that solving questions is very, very important. But the problem is, do we do that or not? Okay. Okay, now for that, we are coming up with this daily, till 75 days, we'll be coming up with this daily session in which we will be solving many, many questions. All right, all right, okay. So now let's try one question. So we are going to do some questions now. So without any wasting time, let's proceed with the questions. And before that, my name is Dr. Umashankar. I am your physics educator. Okay. So here we go with the first question. Let's try this question. I'm very sure we can do it. Please go for it. Please go for it. I'm very sure we can do it. So now in this question, the physical quantity which has the dimensional formula of mt minus 3. So which one is it? So it is the solar constant because surface tension is mt minus 2. Density is ml minus 3. Compressibility is what? 1 upon bulk modulus, and unit of what bulk modulus is megapascal. That is Newton per meter square. So it is ml minus 1, ml minus 1, t minus 2. So obviously this is not the solar constant which has the dimension of mt minus 3. I hope it is fine to everyone. Okay. Okay. Now let's move to the next question. So see, with each of these, you can solve multiple questions. Okay, so in this session, we intend to, solve as much as question as possible, and the live student can ask me if you have doubt in anything. Okay, in any of the question, please go for it. Let's try it. I'm very sure we can do. Very, very simple question. Please go for it. Please go for it. I'm quite sure we can do. Very, very simple question. So, sir, this question belongs from the category of the errors. So, the density of cube measured by measuring its mass and the length of its side. If the maximum error in the measurement of the mass and length are 4% and 3% respectively, the maximum error in the measurement of the density is. So, we know density is mass per unit volume. right? Mass per unit volume, and this volume is given by LQ. The volume is obviously given by LQ. Okay. Okay. Now, if volume is given by L cube, so from here, can I write d rho by rho into 100 is equal to del m by m into 100 plus 3 times del L by L into 100. So we know how to process with the errors, right? So now the maximum error in the measurement of density, so this is going to be 4 and this is going to be 3, and what is the error in the length? It is 3, so it is going to be 9 plus 4, that is 13%. So what is going to be the answer to it? So the answer is 13%. I hope it is fine to everyone, right? Yeah. The live students can please respond to me on this. Okay, let's try one more question. Okay, let's try this one. The live students can quickly respond to me in the chat. Please go for it. Please go for it. So it says the dimension of Wien's constant are. What are the dimension to the Wien's constant? So what is Wien's constant? So it is given by gamma m into t. So this is what? This is the wavelength, right? This is the wavelength, and T is the temperature. Okay, maximum wavelength and the temperature. Okay. Okay, so the product, so it is something into radiation. So when, so we know all this, है ना? So when there is, when we call upon the Green's law, so basically the product of the maximum wavelength to the temperature in Kelvin always remain constant. Okay, so this is length, so it will become m0L. T is here temperature, not time. So T0, and for temperature, obviously it will be Kelvin. So what is the right answer here? The right answer is going to be B. The right answer is going to be B. Okay. 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 Let's try this one. Very interesting question, it seems. So the live students, if you are having any doubt, just a moment. Huh? Yeah. Let's try this one. I'm very sure we can do it. Let's try to solve this one. Very, very easy question. Please go for it. The live students can respond to me. So how we can do it? The live students, please answer me. See, it's a very simple question. You can solve this question, no problem at all. Please go for it. How can we be doing it? Please answer me, guys. So it's a very simple question. It says if the error in the measurement of the volume of a sphere is 6%, then the error in the measurement of a surface area will be. Okay. So now we understand that the volume is basically proportional to r cube. Okay. Radius cube. Okay. So now if so we can write here from here del v by v into 100 is equal to 3 times delta r by r into 100, right? Delta r by r into 100. So now the percentage, if the error in the measurement of volume of a sphere is 6%, so this is 6%, okay, and 6 by 3. So can I write delta r by r into 100, okay, into 100, that is the delta r by r, that means the percentage error in measuring the radius. So it is 2%. So can we write percentage error? So from here, what information did we got? So we got that the percentage error in measurement of radius, percentage error in measurement of radius is 2%. Okay, is 2%. Now, when the percentage error in the measurement of the radius is 2%, so what is going to be the percentage error in the measurement of area? So we understand that the area has to be proportional to r square, right? It is 4 pi r square basically. Okay, so 4 pi has no arrow, it has nothing to do here. So it will be r square. So from here, can we write delta a by a into 100 is equal to 2 times delta r by r into 100. Okay, so it is going to be 2. And what is delta r by r into 100? What is delta r by r into 100? So it is 2%. So basically it will become 2. So it is going to have been 4%. So what is the percentage? What is the error in the measurement of the area? So obviously, sir, it got to be 4%. Right? Again, very interesting question. Right? Now let's move to one more. Let's try this. Let's try this. I'm very sure we can do it. Please go for it. Please go for it. Very, very simple question, guys. The live student can respond to me the answer to this question. What is going to be the answer to this question? The live students, you can please respond to me in this. Anyone? Anyone? Any live students, beta? Do you want to give me some reply to this question? Any answers? Any answers, guys? Very, very simple question. So which is different from others by unit? Okay. So basically simply Poisson ratio, because Poisson ratio we understand that it is a dimensionless quantity. Yes or no? Yes or no? Okay, now let's do one more question. See, these questions from units and measurements are quite repeated. So all these are PYQs only. So these are asked in the examination repetitively. Now let's try this one. I'm very sure we can do it. Please go for it. Very, very simple. We have seen these kind of questions in the, in the sessions also. Please go for it. So the live students, I hope you know that we are having the 75 hard day challenge in physics, and every day at 2 p.m. we'll be coming up with questions on the physics chapter. Okay, let's do that. Please go for it. The live students, please tell me the answer to this. Please go for it, guys. The live students, please respond to me. The live student can please respond to me. So how we can do it? So it says if velocity v, force F, and energy E are taken as fundamental units, then dimensional formula for mass will be, okay. So velocity, force, and energy are taken as the fundamental units, and dimension of the mass, dimensional formula for mass will be. So how we got to do it? So basically here, so this is again a question that refers to the dimensional homogeneity. So we have learned how to create the formula. Okay, so developing the relationship between the dimensions, different physical quantities. So for that we could use the dimensional analysis. So here mass, we can say it is a function of velocity, force, and energy. So let's give them some powers. So let's suppose the power to the velocity is A, the power to the force is B, and the power to the energy is C. Okay. Okay. So see, from here we can do some dimensional analysis. So we can write, okay, what is the dimension here? So it is the mass. So m to the power 0, L to the power 0, T to the power 0 is equal to, if I write, so let's say K is a constant. So you may not use this K also, that is also fine. Then what is the dimension of this velocity? So velocity is Lt minus 1 to the power A. Then this is force. Force is ml t minus 2 to the power b. And what is this E? E is energy. So energy is ml square t minus 2 to the power c. Okay, so these are individually their dimensions. Now what we have to do, sir, we have to compare. So m to the power 1, not 0. M to the power 1, because this is mass now. So here, so we have to compare the power of the same basis. Okay. Okay, so what is the power of m here? So it is going to be b plus c, okay, is equal to 1, right? Okay, in this velocity, we do not have any dimension of the mass. So here, L to the power a, we have, so m to the power b plus m to the power c. Okay, wonderful. So it is b plus c. Now for L, it is going to be A plus B plus 2C, and this is has to be 0. Okay, this has to be 0, right? And now we are having t to the power minus A here, minus 2B here, and we have minus 2C here, and that is also equal to 0. That is also equal to 0. So from here, can we get the values of all these? Yeah. Okay. Now, sir, clearly see, if you use, so A minus 2 B plus C, can we write like this? This last equation is equal to 0. So B plus C is equal to 1. So if I write A is equal to minus 2, I don't think it will be a problem to you. See, I have placed B plus C as 1, and this going to the right hand side, then it will become plus 2, then A is minus 2. Now let's see if we have, okay. So now I can understand that the B and C can never be the answer. Okay, wonderful. Now let A is minus 2. A is minus 2. Okay, now B plus C. So A we can put here in this equation. A is minus 2 and B is the 1 minus C. Okay, B is the 1 minus C. Okay, or we can write like this. Now A already we have. So see, just if you see, just it is what comes in my mind. So can I write 2C? So C plus C is equal to 0. Now A is minus 2, B plus C is 1. So C is going to be how much, sir? C is going to be equal to 1. Now let's see if we come out to the right option. Oh, I think A and D both options are the, oh, so they are given to be same only. I think some misprint happened to be. Misprint happened to be. Okay, there is a misprint in this question. Okay, so basically it is F1 in this option. Okay, F1 in this option. Let's check. So C is equal to 1. C is equal to 1. Now, when C is equal to 1, so B is equal to 0. So what is going to be the solution? So this one is the solution. I hope it is fine to everyone, right? Yeah, what do you say? What do you say? Now let's try this one. So the live students can respond to me in the chat about these questions. They can reply me the answer. Okay, let's try this question. See, we are having this 75 days challenge. In this, we'll be solving questions of the physics as much as we can. Please go for it. Please go for it. So, what is the answer to this? Anyone? Any live student who want to respond to me on this? Anyone, my dear? Anyone who may want to respond to me on this? Please answer me. A very simple question. So, in today's session, till now, we have done 1, 2, 3, 4, 5, 6, and this is the seventh question. Now, see, sometimes see, in examination, we have to save some time as well. Sir, how would we be able to save some time? So, how you would be able to save some time, guys? So, we will be able to save some time by using the key concept that we have learned during our preparation. Okay, right? For example, here we are having two significant figures. Okay, how many significant figures are there? Sir, five significant figures. How many significant figures are there? So three significant figures. So one student may go and go on multiplying all this. But if you know this concept that when two significant figures are multiplied, the final solution must have the same number of significant figures as present in the value with least significant figure. Okay. Okay. So here in the first number, we are having five significant figure. In the second number, we are having three significant figure. So when you do the product of these two significant figures, the solution must be having only three significant figures. Okay. Now in this D option, we are having this three significant figure. So what would be the answer to this? Sir? The option would be this one. Okay. Okay. Now let's move to the next question. The very simple question. Thus, the only purpose of this session is that we get to revise whatever we have learned till now on the channel. Okay, so that you will be more comfortable in the topics. And in the learning series, we are running into this kinematics today at 3:15. I'll be taking the next session in which we'll be covering the graphs in kinematics. Okay, this units and measurement chapter has been completed. Okay. Okay. So we are doing questions on the same. We are also doing motion in a straight lines, vectors also we are into. So many things are happening at a time. Okay, let's do this. Which of the following is a dimensional constant? Let's try this one. So a live student, I can see that students are live. So can you answer me? Please go for it. Please go for it. I'm very sure we can do it. No problem at all, guys. Please go for it. Very simple question. Please answer me. So how could we do it? So which of the following is a dimensional constant? Okay. Now what does that mean? So guys, we have learned this concept that constants some constants have dimensions. Okay. Not all the constants are dimensionless. We know it. So which of the following is a dimensional constant? So refractive index, it is a dimensionless constant. For water, it is 1.33. Poisson ratio is what? So it is the ratio of lateral strain to longitudinal strain. It is the ratio of the lateral strain to the longitudinal strain. Okay. Okay. So see, strain by strain. So it is dimensionless. Okay. This is dimensionless. This is also dimensionless. Strain is change in length upon original length. So length by length. So it is having no unit. So we understand that any quantity which do not have any unit is having no dimension. So it is going to be strain is also dimensionless. Now only one is left, that is gravitational constant. Okay. So this is a dimensional constant. We know F is equal to G m1 m2 r square. Okay. Okay. So here the dimension of G, if I have to get the dimension of G, if I have to get, so it is going to be equal to dimension of F. So dimension of F we must always memorize. So it is MLT minus 2, then R square, that is L square upon M1 M2. M1 M2 are the masses. So this is going to be M square. So this will become M minus 1 L cube, M minus 1 L cube T minus 2, right? M L L M minus 1 L cube T minus 2. Okay, so it is having some dimensions, right? Now let's try one more question. So guys, I hope you are able to solve all these questions. So the live students, I welcome you all, and please respond in the chat that if you are getting the concepts or not. Okay, so see, you have to solve the question in somewhat 60 to 70 seconds of physics. Okay, in the last session I also told you so. Okay, please go for it. Please try it. I'm very sure we can do it. Very interesting question. What does the question say? Please solve it. I'm very sure we can do it. Very interesting question. Please go for it. Please go for it. I'm very sure we can do it. No problem at all. Please go for it, guys. See, unless you try, you won't be able to solve it. Please do it, my dear. See, in the examination, guys, we have to be saving time as well. Chalo, let's do it. So, if E, M, J, and G represent energy, mass, angular momentum, gravitational constant, respectively, then the dimensional formula of EJ square upon m to the power 5 G square is same as that of. Okay, so let's do it. So what is the dimension of E? So the dimension of E is ml squared t minus 2. Sir, how come, sir? Do you memorize? Okay, so I haven't memorized it. I only remember the dimension of the force. So the dimension of the force is mlt minus 2 and energy is Newton meter. So mlt minus 2, mlt minus 2, okay, into L. Okay, mlt minus 2 into L. So what it could be? So mlt minus 2 into L, it is obviously ml square t minus 2. Now what is the dimension of this mass? So mass we already know. What is the dimension of this angular momentum? Okay, so what is angular momentum, sir? Angular momentum we know is moment of inertia into angular frequency, that is omega. Okay, so it is going to be equal to mk square, where k is the radius of gyration, into omega. So what is the dimension to this J? Sir, for mass we have m, for k we have L square, and what is the dimension of omega? Sir, it is radian per second, angular velocity. So it is going to be radian per second, that is t minus 1, right? That is t minus 1. Okay, so it becomes ml squared t minus 1. So the angular momentum is a very, very extensively used term when we'll move to the rotational mechanics. Okay. Okay, so you will see it is very widely used term. Right. Now, what is the dimension of this gravitational constant? So luckily we just have calculated it now. M minus 1 G is M minus 1. Okay, m minus 1 L to the power 3 and t to the power minus 2. Okay, t to the power minus 2. Now we are having the dimension of each of it. Now what is ej square? So ej square ej square, so it is going to become ml square t minus 2. Now see, j is square, so j square will be m square, okay, l to the power 4 t minus 2, okay, because it says ej square upon m to the power 5 upon m to the power 5 upon g square. Hello Shivesh, कैसे हो? Why are you not coming in the live session these days? क्या बात हो गई भाई? All good? आप आजकल लाइव नहीं आ रहे हो, क्या बात है? बताइए. So now I have placed all the dimension in this ej square m to the power 5 g to the power 5. Right? So what is going to be the dimension? So Shivesh, I hope you know that we have started with this 75-day challenge, and in this we will be coming up daily with some questions, right? Okay, we are coming up daily with some questions. Okay, and in this scene, this is the second day. First session we'll have solved some questions, and now in this session also we are trying to solve some questions. Okay. Okay, so how it's going to become? So see, m cube, m to the power 5 minus 2. So m cube will be cancelled out. Then we are having l to the power 6, l to the power 6, l to the power 6 cancelled out. T minus 4, t minus 4 cancelled out. So it will become m0, l0, t0. Now let's check the options here. So option is angle, length, mass and time. So what is going to be the option? So it is angle, because what we learned that the angle is a supplementary unit. Angle is what? Angle is a supplementary unit. Yes or no? Angle is the supplementary unit, right? Okay, and supplementary units are the quantities. Supplementary quantities are those quantities which do have the unit but they don't have any dimension. So when we are getting m0, l0, t0, so that means this whole thing is dimensionless, and then the dimensional formula is obviously similar to that of the angle, right? That of the angle, because angle is a dimensionless thing. Now let's try one more question. Let's try this one. Please go for it. I'm very sure we can do. Please do it. I'm very sure we can do it. Yeah, please answer it. Very, very simple question. And let's see how many questions we have solved till now. So we have solved 1, 2, 3, 4, 5, 6, 7, 8, 9, and this is the 10th question. Please try it. Please try it, guys. I'm very sure we can do it. Very, very simple question. So, sir, it says the refractive index of water measured by the relation real depth by apparent depth. Real depth by apparent depth is found to have values of 1.34, 1.38, 1.32, and 1.36. The mean value of refractive index with percentage error. Now let's try it. Let's try it. So see, so what is the mean value? So to find the mean value, sir, see. So again, see, our purpose is to reach the right option in the minimum possible time. See, this is how you must approach in the examination also, right? You need not to, solve it the same way that we do in our colleges, our pre-boards and all the unit tests, class tests, this test, that test. Okay. So now what is the mean value? So mean value is basically the average value, right? Mean value is basically the average value. So if we took average of these values, we will be getting 1.34 plus 1.38 plus 1.32, right? Plus 1.36, and we need to divide it by 4. We need to divide it by 4. So from here, what we are getting, sir? We are getting 1.35. 1.35. Now, what is the error? Mean error. So the mean error is the error in each of the measurements. So if I say the error in the case of 1, so you would say, so it is the mean value minus the measured value 1.34. So this way you get all the error. But if you see the option, so see 1.35. So this can't be the answer. This can't be the answer. Now, will there be zero error? Now I can clearly see that the value of mean value is 1.35. So definitely none of this is 1.35. Okay, so error cannot be zero. Error cannot be zero. So it cannot be zero. So why? But what is the need of solving all this? Okay, so we can go by the A option, and definitely this is going to be your right answer. I hope that's fine to everyone. Now let's do one more question. Very interesting. Okay, let's try this one. Please go for it. Very interesting. Please try it. Very, very interesting question. The live students, please respond to me, guys. Please go for it. Please go for it. Very simple question, guys. How could we do it? How can we be doing it? How can we be doing it? So very simply, two quantities A and B have different dimensions. Which mathematical operation given below is physically meaningful? Now, can two quantities having different dimensions, they be added? Can they be subtracted? Can they be equal? No, sir. These all are against the principle of dimensional homogeneity. Now, only this is possible. So, two physical quantities which are having different dimension can obviously be multiplied and can be divided. Okay, like velocity, displacement per unit time. Displacement per unit time. Displacement has different dimension, time has different dimension. They can be divided, they can be multiplied, but they cannot be added, subtracted, or they can't be equal. Okay. Okay. So, guys, in this session, we have solved some questions of physics. Again, And this was the day 2 of 75 hard day challenge. So I'll be coming up again tomorrow in this session. We'll be solving some more questions of the physics. Okay. So some more sessions, some more questions of units and measurement, and afterwards we'll move to the kinematics part. So guys, with this, thank you very much. Have a good day. And please don't forget to subscribe the channel, and please like the video, and please share it so that the other students can also come and have participate in this 75 hard day challenge. Okay, so with this, thank you very much. Have a good day.